Alright, this is for lesson 1.2, and we're going to be identifying parent functions to model data sets. So, you guys should be, your page that you're on should look like this, and it says they're supposed to graph the data from the table, describe the parent function, and the transformation that best approximates the data. Okay, before we go on, I want to tell you, why does it say approximates the data? Like, why is it only approximate? When we are only given a table of information like this, and we plot these points, we can't be 100% sure of what exactly is happening between each of those points and beyond those points. However, by having a good understanding of parent functions, we can approximate those values not found on the table. Also, just so you know, the more data points that we plot each time, the more accurately our graph will be, and it will be much easier to identify the parent function which fits the data we are given in the table. Just keep that in mind. Okay, so let's graph the data from this table. And you guys can plot it on here if you want. I'm going to do it on Geogebra once, and that's this other one here. And when you guys open it up, I already have it downloaded, but it takes you to, never mind. It takes you to a screen something like this, and then there should be a download for Windows somewhere here on your screen. So you can do that. It just takes a few minutes, and then it'll be on your desktop then after that. So when you open it up, it should look something like this. And our input bar is down here, which you guys can't see actually. If you can see this now, the input bar is down here on the bottom, and so that's where you type your points into. And scroll up, and then it plots your points. And once again, I already have all of the points put in here and the equations that I need put into this one, so I'm going to use this one. So let's graph those points, negative 4, 8, and 4, 8. Scroll out. So with just looking at these points that we plotted here, what kind of parent function would you approximate this to be? To me, I would say it looks like a quadratic parent function. And now we need to describe the transformation that is happening here. So I'm going to scroll in so we can see this a little bit better. If you look at the parent function of a quadratic function, which I have right here, I'll turn on. And then I'm going to turn this one on. Which one is it? This one here. So I do have a line that fits that there, so we have them both there. What transformation is happening to the one in blue here? And if we aren't sure, we can look at a couple of the key points and see how they have changed. And so on our parent function, okay, so on our parent function here, this one is a key point, and that point being 2, 4. And it lines up with the key point on our transform function at 2, 2. So we have to see how those changed. Okay, so let's write them in. 2, 4, and 2, 4 changed to 2, 2. What translation happened here? We need to see which coordinate changed, which we can see it's at our y coordinate change. It went from 4 to 2. So 4 times what is going to give us 2? 1/2. So we know that that something is happening by a factor of 1/2. Well, if it's less than 1, it's got to be a compression. So is it a vertical compression or a horizontal compression? Well, if it was a horizontal compression, we would be pushing in towards the y-axis, and that is definitely not happening. If it's a vertical compression, we're going to be pushing towards the x-axis here. And that seems to be happening because it's flattening out, you see? So we know, since we figured out what the change was between 4 and 2, that we have a vertical compression by a factor of 1/2. So then looking back at our worksheet here, if you'll fill all this in, that we have a quadratic parent function. Our transformation is a vertical compression by a factor of 1/2. And then draw your graph in here. If you plotted your points here, right away, that's fine. But if you did it on, Geogebra, Desmos, you make sure you put it in here as well. So then when we look at our next one, I'm going to need to plot these points here and see what we get. So let's go back to Geogebra, and I'm going to take these ones off. And then I'm going to plot these points. And this is where, using the, a calculator or a Geogebra or Desmos is great, because, when I graphed this on my paper, I thought it was, a really I thought it could have been, a really stretched out, cubic function at first, just because, you're not very accurate all the time when you graph it by hand. So, here's what it looks like, and that looks like a linear function to me, and on Geogebra here, I'll put my screen up so you guys can see what the tools are. You can do line of best fit, or all I did was I grabbed a line here, and then I put it on one point, and then on the other, and it went through all of them. So it is a linear function. And what is the transformation that's happening to this linear function? Well, that's where we got to look at our key points again. And you can see that the first thing I want to do to make this a lot easier to figure out the transformation that's happening is I'm going to graph the parent function. So I'm just going to graph a linear function here, x, and then I'm going to zoom in where I can see some points closer. And so I'm going to plot one that they're corresponding. So 2, 2 is a key point on this one. So whatever transformation is happening, our points, they change from 2, 2 to 2, 6. And we can look at that just like we did last time now. So we had 2, 2, and that went to 2, 6. Ooh, I can't type. Okay, what happened here? So we saw, again, our y coordinate is the one that changed. So we need to figure out what it changed by. 2 went to 6. So 2 times what equals 6? That freehand is ugly. But 2 times 3. And then since it's a number bigger than 1, then that's how we know that it's a stretch and not a compression. And now the next question that we have is it vertical or is it horizontal? Well, this one, since we're talking about a stretch, we're pulling it away from something, we're gonna, if it was horizontal, we'd be pulling it away from this axis, but it's getting closer to our y-axis. You see that? So we're pulling it away from our x-axis. So this would be a vertical stretch by a factor of 3. And then we'll go back to our worksheet here, and we'll make sure we get all that in there. So it's a linear parent function with a vertical stretch by a factor of 3, and you put in your graph. So after you guys get that last one graph that we did together, you have a couple here to do on your own, and the last one here is, I know we didn't cover anything like this, but it's just a word problem dealing with the same stuff, and it corresponds with example number 3 in lesson 1.2 if you guys need a reference, but it's seriously the same thing, because you have a data set here that you need to plot onto this graph, and you have to label your axes, because I didn't give you the right kind of graph, I guess. And then it's going to ask you what to estimate the cost for 5 months of online service. And you can graph it all on here and estimate it. But what I did, which is fairly easy, is I plotted all my points in Geogebra, and then I saw where, 5, what the value was at 5. So I was going to give you that tip, and I forgot to. So don't be afraid. Don't be afraid to use Desmos and Geogebra. Whenever you need to. They're very handy tools. So